All right, this is an investigation to help prove certain angles are congruent. And so you are more than welcome to try this on your own and then check your answers afterwards. Either way, the first thing you're going to have to do is take that little square piece of paper I gave you, and you're going to need to trace the diagram at the top of the page. So that you're going to take your patty paper, the little square sheet, and you're going to trace over everything, as well as labeling all the angles and then the lines. And what you will do is, after you've traced it onto that paper, you're going to end up moving them around so that way you can place the angles directly on top of each other, and the see-through angles are going to be able to, or the see-through paper is going to help you identify what's the relationship between the angles. So in looking at this, you'll notice that in the directions it says to use words like congruent, supplementary, can't determine when you're talking about describing the relationship. So the first thing we're going to do is talk about corresponding sides. If you want to try this on your own and pause it right now, this would be an excellent time. Okay, so either you have unpaused the video and you've done this all and you're going to see if you got it right, or you are waiting it out and you're going to do it with me. Corresponding angles. Corresponding angles, the examples of them are 1 and 5, 4 and 8, 2 and 6, 3 and 7. So take your patty paper and place angle 1 on top of angle 5. See what you notice. What about angles 4 and 8? If you place the patty paper on top of angle 4, or take the patty paper and put angle 4 on top of angle 8, what do you notice? Now try placing 2 on top of 6 and 3 on top of 7. Hopefully you notice that in each of these cases, they were all in the same position. And they were on the same side of the transversal. Because I write really big on this thing, all of these have the same description of the relationship, that each of them is in the same position. If you look at angle 1 and angle 5, they're both on the same side of the parallel line. 1 is on top of R, 5 is on top of S. And they're both on the same side of the transversal, meaning both 1 and 5 are on the left of line T. For 4 and 8, 4 is below R, 8 is below S. They're both on the left of T. For 2 and 6, 2 is on top of R, 6 is on top of S. They're both on the right of letter T. And for 3 and 7, 3 is below R, 7 is below S, and they're both on the right of T. That's what makes them corresponding angles. So the conjecture would be, what do you notice about the relationship between corresponding angles when you have parallel lines cut by a transversal? The parallel lines in this case are R and S. T is the transversal because it's a line that goes through the parallel lines. So we would note that the corresponding angles are in the same position, on the same side, of the transversal. This now means that corresponding angles are congruent, meaning if you know one of them, you know the other one. So if you know 1, 5 will have the same measure. If you know 4, 8 has the same measure. If you know 6, 2 has the same measure, and if you know 7, 3 has the same measure. So now we're going to look at examples of supplementary angles. So the thing to note about supplementary angles is it's two angles that share a line and are split by a transversal.
Sorry to interrupt you.
So take a look at 2 and 3. Notice that 2 and 3 are both on the right side of the transversal, and these ones are actually split by R. And so that's what makes angle 2 and angle 3. Same for angle 5 and angle 6. Those are both on the same side of S, and letter T splits them. Additional examples are angle 1 and angle 2, angle 1 and angle 4, angle 3 and angle 4, angle 5 and angle 8, angle 6 and angle 7, angle 7 and angle 8. All of those, so in total, there's 8 pairs of supplementary angles. Now for vertical angles, if you look at 2 and 4, what do you notice about them? Same for 5 and 7. What do you notice about their positions? Well, hopefully you've noticed that they're opposite angles that are formed at an intersection. One thing you should note about vertical angles is they will be congruent. We know supplementary are going to equal 180. Vertical angles are congruent. When you're asked to name additional pairs of vertical angles, there are 2 other ones. On top you have angle 1 and angle 3, and on the bottom part you have angle 6 and angle 8. Now we're going to look at the 2 newest types of angles, alternate interior and alternate exterior angles. The reasons that you haven't seen these before, whereas you've seen corresponding angles, you've seen vertical angles, and you've seen supplementary angles, is because these 2 angles can only be formed when you have parallel lines cut by a transversal. For alternate exterior angles, they give you the examples 3 and 5, 4 and 6. So take angle 3 and put it on top of angle 5. Or take angle 4 and put it on top of angle 6. What do you notice when you put them on top of each other? Well, hopefully you notice that they are, in fact, congruent. And regarding the relationship, you should note that they are on the interior of the parallel sides on opposite sides of the transversal. So 3 and 5 are between R and S, but notice that 3 is on the right of T and 5 is on the left of T. 4 and 6 are on the inside of R and S, but 4 is on the left of T and 6 is on the right of T. So regarding the relationship, those 3 parts that I've underlined describe the relationship regarding alternate interior angles. And hopefully you notice that when you put 4 on top of 6 or 3 on top of 5, they ended up being the same measure. When you come to alternate exterior angles, place 1 on top of 7. Or place 2 on top of 8. Or you could put 8 on top of 2 or 7 on top of 1. What do you notice? Well, hopefully you notice that for these are also congruent angles. And regarding their position, they are on the exterior of the parallel lines, and they're on the opposite sides of the transversal. So if you look at number 1 and number 7, they're on the outside of the parallel lines. 1 and 7 are on the outside, but 1's on the left of T and 7's on the right of T. Or for 2 and 8, they're on the outside of the parallel lines. 2 is on top, 8 is on bottom, but 2 is also on the right of letter T, of line T, and 8 is on the left of line T. So that's what they mean by outside or exterior of the parallel lines and opposite sides of the transversal.